Now let's look at a vertical shift. We're going to sketch a graph of y equals 3 times the sine of x. So that's going to be a vertical shift by 3. We know if we take any function, we multiply it by 3, it's going to triple the y values, we get a vertical stretch by 3. They call that the amplitude, how high the waves come off of the x-axis for the original graph if we haven't done any translations in the y direction. We call the height of the waves the amplitude, and here the amplitude is going to be 3. So let's see if we can draw this thing. So again, let's start with the basic graph. We're going to do a vertical stretch, so let's go ahead and label the x or the y-axis appropriately here from -3 to 3. So the original sine graph goes 0, 1, 0, 1 hump going up, -1, 0, 1 hump going down. And then if we graph y equals 3 sine of x, that's simply a vertical stretch by 3. Which if we take these 5 points and we multiply the y values by 3, we're going to get 0, 3, 0, -3, 0. So we get the same picture, but the waves are taller. We say there's an amplitude of 3. If you measure the distance off of the x-axis, the distance from the x-axis to the top or bottom of these waves is 3, so we say there's an amplitude of 3. So that's how you do a vertical stretch of a trig graph. If you have y equals a times sine of x or cosine of x, we've only done sine examples so far, but if we have sine or cosine, you multiply by a, we say it changes the amplitude of the graph to a because the graphs get stretched. Instead of being from -1 to 1, they're from -a to a. Okay, so in general now we can combine a couple of things that we know about vertical stretches and horizontal stretches or shrinks. And if we look at either sine or cosine of x and we do the transformations and we look at a times sine of kx or a times cosine of kx, then if a is negative, we're going to reflect the graph across the x-axis like we did with negative sine of x. But the absolute value of a will be the amplitude, how tall the graph is. And then we know if we replace x with k times x, we get a horizontal shrink or stretch depending on k. And remember, those work backwards. If, let's say, k is bigger than 1, you're going to get a shrink by 1 over k. So the period will go from 2 pi to 2 pi over k. So the horizontal stretch affects what we call the period of the graph. And, of course, these things are periodic. And you could draw any period of the graph, but one complete period. Usually, if you haven't done a horizontal shift, we draw from 0 to the period, which would be 2 pi over k in this most general case. So let's look at a couple examples here. We're going to do 3 times sine of 2x and -4 times cosine of 1/2 x. So we have y equals 3 times sine of 2x. Now it's a good idea to start by listing the amplitude and the period. So the amplitude of this graph will be 3. Let's see, it looks like I chose gray instead of black. The amplitude will be 3, and then the period will be 2 pi over k in general, which is 2 pi over 2 here, since k equals 2, and we get pi. Okay. To relate this to earlier in the course, if you replace x with 2x, you get a horizontal shrink by 1/2, so the period goes from 2 pi down to pi. Now, to me, the easiest way to draw this is just to relabel the axis to accomplish the stretches and shrinks. We can always go 1, 2, 3, 4, but label the period, which is now going to be pi instead of 2 pi. Which if you divide that by 4, that means my smallest tick mark, my scale here, is pi over 4. So we have 1 pi over 4, 2 pi over 4, which would be pi over 2, 3 pi over 4, and then 4 pi over 4, which would be pi. And then if my amplitude is 3, I can simply use that as my scale if I like. I mean, I could count by ones, but we could count by threes on the y-axis. And now we've got it. We're drawing sine, so 0, amplitude, 0, negative of the amplitude, 0. So I've really done a vertical stretch. The graph, instead of having a height of 1, has a height of 3 now. And we've done a horizontal shrink and changed the period to pi instead of 2 pi. But I've accomplished that by the way that I've labeled the axis. That's the way that I prefer to do this. And then I always draw the same graph with the same 5 points. Okay, now we'll look finally at a cosine graph. We're going to do negative 4 cosine of 1/2 x. So here the amplitude is 4, okay, the absolute value of a. It's also got a reflection across the x-axis, but the amplitude is 4 because it's a distance. The period is 2 pi over k, so 2 pi over a half, which is the same thing as 2 pi times 2, or 4 pi. If you put in a half, you get a stretch by 2 to 4 pi. So we can draw this thing. Just like sine, we do 4 tick marks out to the period, which is 4 pi, which here it's nice, that makes the scale, if we divide by 4, pi, 2 pi, 3 pi, 4 pi. Let's see, I think I'm going to count by 2's, negative 4 to 4 to show the amplitude. So if we drew cosine, let me first draw it without the negative. So cosine begins and ends at the amplitude, and then goes 0, negative a, or negative 4 in this case, 0. You get a U shape that's maxed on the ends and has the min right in the middle, in this case at 2 pi negative 4. We do have a negative in front. This is the graph of y equals 4 cosine of 1/2 x. If we want to show the negative, we have to do the reflection. So we change the signs of the y values. And there's y equals negative 4 cosine 1/2 x.